architecture is critical for you to understand as you develop code or even manage teams which develop code, or in the business of architecting code. This loop becomes critical. Our constant effort is to try and make sure that the software professionals know what the hardware teams are doing at the appropriate abstraction level, and the hardware guys, back in our company, have a good sense of how the software behaves, so that we can take advantage of the platform. And the innovations you see in multi-core and threading and parallelism and hardware-assisted virtualization are some examples of what we've learned over the years and put back into silicon. Let's see where we are headed. I gave you some examples of machines which are 128 threads coming up over time in terms of server. On the client side, on your laptops and desktops, on your gaming machines or your consumer machines or your productivity machines at work, one example of what is available today is a Core i7 processor. It has 4 cores in it, and each core has at least 2 threads running, depending on hyper-threading enabled. Where we are headed is an example of a product codenamed Larrabee. Larrabee initially is targeted to be a graphics processor, which will basically take the knowledge base you already know in terms of x86 programming and in your favorite language, and then extends that in terms of the flexibility. It doesn't force you to change the way how you program, but take advantage of how you program and put it into a new architecture. So what you see here in the bottom half of the diagram is that the little blue boxes are basically multi-threaded SIMD cores. These are, if you can think, small chips. About 32 of them will be into one chip, and this is what we call our many-core architectures, moving away from dual-core to quad-core, which we typically refer to as multi-core, to many-core architectures where we'll have 32 cores, each core potentially running at least 1 or 2 threads, with a significant amount of bus available inside the chip for that, so that the apps can interact with each other, and of course memory controllers and interface. Now this is going to sit off a system bus. Why does the reason I show this sort of extreme example, this product is not out, this product will be out over the next 18 to 24 months, is that the direction in which many of the computing elements is headed is illustrated by this, that we're moving from dual core to multi-core to many-core in most of our platforms. You saw the server example, the 128 threads. We're seeing some examples which will sit on desktops and potentially over time on laptops with that kind of compute power. The key element in this is the application taking advantage of parallelism. Parallelism is everywhere. Multi-core is everywhere now, from weather modeling to web services. Now, if you think about it, web services to weather modeling is quite an extreme scenario in terms of performance requirement. We all know weather modeling is complex, lots of variables to be processed, lots of third-degree equations to be resolved, and lots of data points to be correlated and inferences to be drawn to try and get a summary whether it's going to rain tomorrow or not. As simple as that. But there's lots of processing happening and lots of inferences happening. Now you might be thinking, well, dude, I don't do weather modeling stuff. I write business applications. I write services. I do web services. I provide financial applications or manufacturing applications. With the advent of things like Silverlight, from Microsoft, and these rich internet technologies coming onto your client, a variety of things are beginning to impact the consumers. I talked about growth through innovation and stimulating growth through innovation. What I'd like to force you guys to think is, as you write your applications, you want to start thinking, am I making somebody's life better? Am I making some business user or consumer's life slightly easier? Am I making my interface more intuitive? Am I trying to collect the right pieces of information and putting them together? One of the internet terms, or the Web 2.0 terms, which is popularly used, is things called mashups, where effectively you take something and you take something else, you put them together, and make 2 plus 2 greater than 4. The point I bring up here about web services is that with frameworks like Silverlight, you get tremendous flexibility in trying to create more and more of these mashups on the client infrastructure itself. You don't need to sort of push everything onto the cloud. A lot of that intelligence can be brought onto the Silverlight platform on the client side and make the task much easier. Common example, you're trying to book a flight, you go to some of the popular travel portals, you want comparisons from X number of airlines. You're trying to get movie tickets, you're looking at different theaters, you're looking at options, you want to get the data points and see which show works out for you. Now all these in some ways are folks like yourselves sitting at the back end and writing the code for that, sending out whether it's XML queries or whatever language you're comfortable with, sending out those queries, collecting more and more information, building it in some intelligent form and bringing it to the user. We believe that this has tremendous potential going forward as we bring more and more mashups on the client side. You can start imagining that not only do you start bringing services from different portals, but also start using device capabilities. For example, you're building a banking authentication application. You try to authenticate yourself with the bank. The bank says, if you really want to do a high volume transaction, I'm not only going to authenticate you with the password, but potentially authenticate you with the fingerprint reader on your laptop, which is available, if available, and then the transaction becomes even more secure. And if that gives comfort to some people, or some trusted platform module which might be on your hardware, or voice recognition. Steve talked about gesture yesterday, or face recognition. The laptop I have at home has a simple webcam. What it does is, it gets your password. But if you enter the password incorrectly, it captures your image and creates a log of it, saying, this particular individual with the face was trying to get into your machine and had mistyped the password 3 times, and it keeps a log. So when I get in, I can say, well, what actually happened. I caught my mom, trying to enter into the machine and entering the wrong password last week, and I showed her. I said, look, it recorded you at that point. She was very upset. Said, wait a minute, you didn't tell me this thing records. So it's simple use of technology, but the question is, the creativity is how do you actually convert that to user value, right? Russell mentioned beautifully that he sits and observes sound. Now it's a concept which for most mortals like us is a little difficult, right? And for us it's either music or it's noise. But he observes sound, he can dissect sound, right? That's our brain trying to analyze human behavior, human patterns. I think the move to the next value chain for most software professionals is to start to understand what exactly makes value to the users, in addition to the use of technology, and how do I take these pieces of technology and make it relevant to the user. The webcam is like a commodity these days, right? It's a 1.3 megapixel webcam, no great shakes, but in a combination of webcam, password, things suddenly made it even more interesting, right? And it recognizes your face, and you don't need to enter password sometimes if the right conditions are correct. Although I think there's a lot of work to be done in that particular element. I have ordinary laptop, and I realized that when I bought the laptop, it has 6 speakers on it. It has Dolby 5.1 something, and we started doing a lot of Skype and Yahoo chat type of things, with my siblings who live across the world. And over time, we realized that sometimes we are connected for over 2 hours, where you've got a webcam on that side and webcam on this side, and literally the notebook is sitting in the kitchen, that the family is getting so close that my mom knows what my sister's cooking and my sister knows what my mom is cooking, and they're beginning to literally have a conversation as if they were in the room. Right now, this is a very simplistic consumer behavior. I was in a store last week and I said, what if I put an HD cam on top of that? And not only HD cam, but I started adding filters in terms of noise, so I can cut out things which come from the directional mic. And you start to create applications. I was meeting a software company in Taiwan last Monday, and they said, how many of you have lots of pictures on your hard disk? Okay, good portion. If I told you, well, pull out all the pictures with your child in it, right? Have you all named them and tagged them correctly and labeled them and put them in the right folders? How many of you have done that? Boy, 70% drop, right? What the software does is, you take the picture of your kid,